Welcome back, GED scholars and math warriors. In this video, we're talking all about algebra. So welcome to Algebra 101. In this video, we are going to discuss the order of operations, and we're going to discuss the algebraic expressions as well. If both of these terms or one of these terms is new to you, please make sure you pay attention to this video. Also, we are going to be covering word problems, and so we already have two videos, Math Word Problems 101 and 102, that can help better explain the 4 steps to completing word problems. So the order of operations is the math world's way of letting you know that when you see a equation or an expression and there is a lot happening, you'll notice that a couple of numbers are being multiplied, maybe some numbers are being added or subtracted from one another. And so what we need to do is we need to know this order of operations, and that's going to tell us exactly where to begin. And so there's a saying that can help you remember this order. Please excuse my dear Aunt Sally. And each of the letters that begins the word is going to stand for the order of that operation. So when you see an expression and you notice there are things happening in parentheses, that's where you're going to start. The next place you would go to is you would complete any exponents or roots. And hey, we have a video on exponents and roots. So if you're like, I have no idea what that is, check out those videos we have for you. After exponents and roots, you would complete any multiplication or division, and then finally any addition or subtraction. And folks, we are reading these expressions, these equations from left to right. So if I start on the left and I notice there are addition problems happening in the beginning, and after that there's some multiplication taking place, I have to take care of the multiplication before I take care of the addition or subtraction. As this information tells us, this is an order. This is the math world's way of saying you have to complete all of these operations like this in order to get the correct answer. So let's look at an example. So we're going to use the example 5 plus 3 squared over 4 plus 3 times negative 1. So as I mentioned, there's a lot going on, right? And the math world is like, hey, just remember, please excuse my dear Aunt Sally and you'll be fine. So if I'm paying attention to this, what's the first thing I need to take care of? Yep, if you said this numerator, absolutely. There's a lot going on, and this is where I'm going to first start. So I need to take care of what's happening in the parentheses. So 5 plus 3 equals 8, and so it's 8 squared over 4 plus 3 times 1. So 8 squared is an exponent, and I know that's number 2, so I want to take care of that. Folks, there's a video about exponents as well, so make sure you check that out if you're like, I don't know what an exponent is. So what's happening with this numerator right here is it's being raised to the power of 2. So 8 squared is not saying 8 times 2, it's saying 8 times 8. And 8 times 8 is 64. So I'm going to write down my 64, and it'll be divided by 4, and then plus the 3 times 1. So I've already taken care of the parentheses for the numerator along with the exponent. Now I need to go to number 3, which is multiplication and division. And folks, remember, we're going from left to right. So I need to take care of 64 divided by 4 first. If you need to use your calculator, please grab the calculator. You know I am a fan of using the tools that we can on this exam. 64 divided by 4 is 16 plus 3 times negative 1. And I forgot to put the negative over here. I should have remembered. So now I know, okay, up next is the multiplication, which is happening right here. So 3 times negative 1 is negative 3. So now I have 16 plus negative 3, and that's going to give me 13, folks. And I'm going to pull up the calculator to show you that the calculator understands the order of operations, but sometimes you might need to help it out. And sometimes you're going to notice that, hey, whatever you saw or whatever you were given on the exam as far as the equation or the expression is concerned is what you're going to input into your calculator. So if I was to get this on the exam, I'm going to do open parentheses, 5 plus 3, close parentheses, raise it to the power of 2, and the calculator has a specific button when you want to square things. And then I'm going to divide by 4, and I could either use the division key or I could enter this as a fraction. But as some of you know, when you have a fraction in the calculator, you need to really pay attention because you have to end up arrowing your way out of the fraction to enter numbers. So divided by 4 plus 3 times -1. And notice for the times -1, I didn't even do the time key. I just put the -1 in parentheses next to the 3. The calculator knows exactly what to do from there. So now I'm going to hit enter and we get 13. So once again, as long as you're inputting the equation correctly into the calculator knows what to do. So let's look at a problem where if we were to go to our calculator, we're going to need to add parentheses. So I have 15 plus 25 over 2 times 5 plus 6. So when I look at this problem and I know, okay, I'm going to start on the left and I know that I need to take care of this fraction. This needs to be taken care of. But more importantly, I need to take care of the numerator first because I'm starting left to right, but I'm also going top to bottom. So 15 plus 25 is 40. And I'll draw this line because I know the next thing I'm going to do is go down to the denominator. And I'm going to say 2 times 5 is 10. And so now we have 40 over 10 plus 6. So 40 over 10 or 40 divided by 10 is going to be 4 plus 6 equals 10. When I was taking care of this, I mentally added those parentheses to kind of tell myself, hey, you need to take care of this group or this operation, the sum of 15 and 25, before you can go and you do the multiplication in the denominator. So I mentally added those parentheses. Well, folks, you're going to need to do the same thing though. Well, literally add parentheses if you were to do this on your calculator. So 15 plus 25 divided by 2 times 5 plus 6. And we get 83.5, which we know is incorrect. So let's add those parentheses. So open parentheses, 15 plus 25, close parentheses, divided by, open parentheses, 2 times 5, close parentheses, plus 6. And we get 10. So folks, you just have to remember that sometimes you might see an expression on paper and you think, wow, I can do this without the calculator, and go for it. Do it without the calculator. But if you need to check your work and you notice that on paper or on the screen, they're not giving you parentheses, but you're like, I know parentheses need to exist the way we knew they needed to exist around the numerator and the denominator, then that's what you need to do to move forward with using your calculator. So the next problem, folks, is 4 times 3 minus 2 plus, open parentheses, 6 plus 4 times 2. So there's a lot going on, like the last problem we looked at. And obviously we know we're following the order of operations. Please excuse my dear Aunt Sally. So the P, what do we see is all the way on the right, we see addition happening and then multiplication. Remember, multiplication happens first before that addition takes place. So what I need to do is I need to do 4 times 2, which is going to give me 8 plus 6. And that's going to be 14. Had we done 6 plus 4 times 2, you would have gotten 20. And 20 and 14 are obviously different numbers, and you would have gotten the wrong answer. So that's why it was important that first we did the 4 times 2 to get 8, and then we're adding the 8 to the 6 to get 14. So now let's go to the other side of the equation and pay attention to this multiplication. So 4 times 3 is 12. And then we're going to bring down the -2 and plus sign to follow through with plus 14. So 12 minus 2 is 10, plus 14 is going to give us 24. Let's go ahead and pull up our calculator and toss it in the calculator and make sure we're adding the parentheses so we get that right answer. So let's clear our screen. And we're going to do 4 times 3 minus 2 plus, open parentheses, 6 plus 4 times 2, close parentheses, enter, and we get 24, which is the correct answer. So for this one, we have 5 squared minus 5 minus 7 in parentheses times 2. So what's the first thing we do? We are going to take care of the parentheses. 5 minus 7 is -2, and it's multiplied by 2, and then I have 5 to the power of 2. So parentheses first, exponents next. 5 to the power of 2 is 5 times 5, which is 25. So next I need to take care of multiplication, which is this bunch right here. So -2 times 2 is -4. So I have 25 minus -4, and that'll give me 29. Let's pull this one up on our calculator to double check our work. And let's go ahead and enter 5 squared minus, open parentheses, 5 minus 7, close parentheses, times 2. And we get 29, folks. So we know that's our answer. And if you're looking at the calculator and you're like, wait, you didn't even do 5 minus 7 times 2, you just added the 2. That's what I meant, folks, when I said the calculator understands the order of operations. So it knows that when I just place the 2 outside of a parentheses, that I want those numbers being multiplied together. Next, let's talk about algebraic expressions. And folks, you see on the screen a table, and I want you to either take a screenshot of this table, look one up on your own, you can Google it, whatever you want to do. It's important for you to understand how these expressions are described in words and how it looks when you convert it into math talk, when you convert it over into those symbols. So for the first one, it says the product of 6 and a number. And folks, the thing is that in algebra, there's always going to be a number that's not known. And they end up calling that number a variable. A letter stands in its place. And so we see in the symbols, the product of 6 and a number, we have 6x. The next line says a number decreased by 10. That means you're subtracting. So a number, x, decreased minus 10. And you also want to pay attention to the order as well, because if it had said 10 decreased by a number, we would have ended up writing 10 minus x. So the order that the words are appearing matters as well. The next line reads, the sum of 5 and the square of a number. So the sum means adding. So they're showing the sum with this with this addition symbol right there. And they're saying 5 plus the square of a number. So you're raising that number to the power of 2. And remember, when you do that, it would be x times x, not x times 2. You're repeating that number. The next one is important to pay attention because the phrase says 6 less than. Okay, that's important to pay attention to because there's a difference, or there's a different way of writing when it says less than versus if you look at the line, the last line where it just says less and there is no less than. So when it says 6 less than the quotient of a number and 2, whenever it says any number, whether it's like 5, 4, whatever, and it says less than, it means you need to put that number at the end of that equation. You're not going to do 6 minus the quotient of a number. If you did that, it would say 6 less the quotient of a number. It says 6 less than, which is really important, folks. Pay attention to that. The next line reads 1/2 a number increased by 10. So 1/2 is 1 over 2. A number, introducing a variable again. Increased means adding by 10. Next line says 5 times the difference of -2 and a number. So we know that when a number is times another one, we're multiplying, and difference means that you're subtracting. The next line reads a number less than another number. And there we go, folks, with this whole concept of less than. Okay, this one's a little bit harder to use as an example for less than because we're using variables, X and Y. And you could use any variable or any letter to stand for a variable, but you understand that concept. But that last line, you guys, notice how it says 10 less the square root of a number plus 5, and it gives us that 10 at the beginning of the expression. So 10 and then less, which means minus the square root of x plus 5. So just make sure you're really paying attention to the difference between the less and the less than. Let's get into some examples though. So it reads, a team is giving a local charity the sum of $1,500.50 for each ticket over 2,000 sold for one game. Let T represent the number of tickets sold. If the team sells more than 2,000 tickets, which of the following expressions could be used to find the amount of the donation? So I want to make sure to pay attention to those terms that we know are letting us know exactly what has to happen. So I want to pay attention to the sum of $1,550 for each ticket over 2,000 sold. So automatically, I know that there's going to be an addition sign and two numbers are going to be added. The first one is 1,500 plus 50 cents for each ticket over 2,000 sold. So it's not 50 cents per ticket. It's whatever is the excess of 2,000 sold. I highly suggest that once you get used to these different type of exams, that start deleting or eliminating answer choices where you're like, wait, this won't work at all. The reason I bring this up is because look at D. D does not have the addition symbol anywhere, right? But we know it says right up here, the sum. We know there has to be an addition symbol somewhere. D doesn't have it, so D cannot be my answer, and I'm going to automatically kick it out the window. I don't need it there bogging up my mind and making me wonder, could it be this? Could it be that? The other one I want you to look at is A. So A starts the way we want it to, 1,500 plus, but then it's saying 50 cents per all the tickets sold because T represents the number of tickets sold. But we go up to that first line and we know that the 50 cents is for each ticket over 2,000 sold. So it's not 50 cents for every ticket sold. We're going to get rid of A as well. Notice in B and C, the difference between these two is what's happening in those parentheses. And the thing is that it's 50 cents for each ticket over 2,000 sold. So when we know it's over 2,000, that the first 2,000, you're not going to get 50 cents. They're saying out of the total amount sold, the first 2,000, nothing. So take the total amount, get rid of the first 2,000, and whatever's after that 2,000, that is what we're going to multiply by 50 cents. Well, folks, if you just followed what I said verbally, when I said they're gonna take the total number of tickets sold and then minus 2,000 from that, you know it's going to be letter C. That is the equation that we would use to figure out the amount of that donation. Just make sure you're paying attention not only to the wording, you guys, but even if you get stuck with the wording, do some common sense and think to yourself, okay, if the total number of tickets sold is more than the 2,000, this is going to end up with a negative number multiplying the 50 cents, which is not what we want at all. So C is our answer. Okay, folks, one more example. This says the sum of 5 times a number and 4 times a number is divided by the sum of 2 and a third number. Which of the following expressions represents the series of operations? Well, we got a lot going on, and what I did notice is the word sum. So I'm going to go ahead and just put my addition sign there. The sum of 5 times a number. And remember, when we see a number, it's a variable, so we need to add. So we have 3 variables here. And as you can see from your answer choices, we're going to use X, Y, and Z. So the sum of 5 times a number, which is X, plus 4 times a number, and we'll use Y, divided by the sum of 2 and a third number, and we'll use Z. And folks, this is just the framework. But when I look at this setup of this equation, and I see all these operations, I know the way we did with the other problem that didn't give us those parentheses, but we were smart enough to know that, hey, I need to take care of the numerator first before I go down to the denominator. And we mentally added those parentheses around the numerator and denominator. And when we even went to our calculator, entered the numbers without parentheses, it gave us the wrong number. We know we need to add these parentheses to protect the sum of whatever is happening in my numerator and the sum of whatever's happening in my denominator. So going to our answer choices, is there an answer choice where you see all of the expressions and operations written out correctly with parentheses? Yep, if you said D is our answer, you got it, folks. D is our answer. Great job, you guys, on taking care of these problems. Make sure you go to gedtalk.com resources. We have a 30 problem worksheet with answers. We have a lot of other worksheets that you can download for free to make sure you are practicing every day until you take your exam. Thanks for watching, GED scholars. You know what you're doing. Keep your head up. You've got this.